So, if the phase is positive or negative, that's how you find out if it's
Yeah, the phase shift being positive or negative identifies which direction that the graph slides, left or right.
so if it's positive, it's to the left.
Yeah, correct. Now I'm looking at number 4 here on page 88. This is the problem. Y is equal to 4 sine, in parentheses, 2x minus pi over 6. So the amplitude is here. So I would say the amplitude of this thing is going to be equal to 4 units. Okay? Now to find the period and the phase shift, I'm going to factor 2 out of 2x minus pi over 6. So I'm going to rewrite this as y is equal to 4 sine, factor 2 out of x minus pi over 6 becomes x minus, what do you think? What's pi over 6 divided by 2? Pi over 6 times 1/2. Another fun phase shift. Pi over 12. Okay, but it's minus. So the phase shift is going to be equal to pi over 12 units. Since it's subtracted, we go to the right. Okay? The period will equal to this expression, 2 pi over the absolute value of b, which is 2. And it's going to be a positive 2. So the period is pi. So the first thing I want to do here is this. I'm going to graph my standard sine curve from 0 to pi. I'm going to mark this in increments of 4 since I know my amplitude is going to be 4 units. I want to make sure I've got enough room here. Try to scale this as best I can. Doing this free-handed is not the best, but I know there's graph paper background, so I just want to make sure that.
Is it possible to have no phase shift?
Yeah, there'll be some of these problems left without a phase shift.
Mr. Sheriff, can you move to the left? That's you.
Okay, now listen. When I graph the sine curve,
That way
the
you're like-
standard sine curve, this is what's going to happen. According to the dimensions that I've given this thing, the way I had to scale the vertical axis to try to get all this in here, this is y is equal to sine x. Okay? Now, I think the next thing I want to do here, before I start to consider the phase shift, I want to consider the graph of 4 sine 2x. Let's do that first. I'm going to do this one in green, okay? So the next thing I want to do to help understand what's going on with this, I'm going to graph y is equal to 4 sine 2x and see how the phase shift compares with this. So 4 sine 2x. First of all, we need to understand the period is pi units, and so what I want to do is break down this into the proper intervals, right? 1/4 of pi is pi over 4, then I move to pi over 2. 3/4 of the way is 3 pi over 4, and then I stop at pi units. So my period is pi units here. Now the standard sine curve, well, not standard sine curve, the sine curve, 4 sine x would go all the way up to 4, down through pi, down to a negative 4. But what I want to do is I want to graph 4 sine 2x. That's going to look like this. We'll start here. Okay, that's basically what it looks like. I didn't draw this down far enough here. The next thing I'm going to do to figure out what this curve looks like under the phase shift, pi over 12 units to the right, is I'm going to take each benchmark here, 0 radians, pi over 4, pi over 2, 3 pi over 2, and pi, and I'm going to, in red, indicate where the graph would, let's say, begin, where the y value that gets kicked out is 0. I'm going to move everything to the right, pi over 12 units. So I know if from the origin, I know that this I'm going to approximate here. Let's say that represents pi over 12 units. going to be a little bit more work to identify pi over 12 units past each one of these other critical junctures when I'm trying to figure out the graph of this sine curve. Now to figure out where we're going to establish the quarter mark of the curve past pi over 4, I'm going to add pi over 12 to that. And what I did here in doing that, I get to pi over 3. Now we got to find pi over 12. We're going to say pi over 2 plus pi over 12, and that's going to be 7 pi over 12. All right, so where is that going to be? It's going to be about right here, we'll say, 7 pi over 12. Then I want to say 3 pi over 4 plus pi over 12. What's that going to end up being? 9, 10 pi over 12, which is 5 pi over 6. Okay, so I'm going to end up right here at 5 pi over 6. All right. Now for the last benchmark, I've got pi plus pi over 12, which is going to be 13 pi over 12. All right. So now what this means is this. My curve reaches a high point of 4 at pi over 3. It's going to go back down to the x-axis at 7 pi over 12. It's going to reach a minimum of a negative 4 here at 5 pi over 6. Then at 17 pi over 12, it goes back up to the axis. So basically, if I were to graph this from 0 to 2 pi, all right, 1 or 2 people paying attention. It would start right around in here. It's enough just to guess, to sketch this right here, all right? And then I'm going to stop it about right here. This would be my fundamental period, all right? From 0 to pi. It would actually start right here and end just below the x-axis, right in here, where it would end. Right here is where it would actually start.
Let's say for the first one, 13 pi, and 13 over 6. The first starting point.
Pi over 12, pi over 3, 7 pi over 12, 5 pi over 6, then 13 pi over 12. That's what I did to get a picture of the graph that gets translated. Pi over 12 units are shifted to the right that much. That's what the actual curve would look like, beginning at pi over 12 and ending at 13 pi over 12. Looks just like the graph of 4 sine 2x from 0 to pi.
What's the last one?
13 pi over 12. That's the 13 right here.
Wait, I have a question.
Y'all listen up here, okay? Listen up. Before I identify what's going on here, number 7, I'm going to go ahead and amend my directions for you on what I want you to do for your time, okay? On 7 through 12, I'm going to go ahead and just say, just identify the phase shift, okay? Just identify the phase shift. What I'm going to want you to do on 13 through 20, so I'm going to give you through number 20 to do. I want you to graph those. So you don't look too hard. You haven't even looked at it. Don't panic on me, Harry, until you look at the problem. But when I'm looking at y is equal to 3 sine x over 6 plus 2 pi, to find the phase shift, I've got to factor out the coefficient of x over 6. And what is the coefficient of x over 6? 1 over 6, isn't it? So I've got y is equal to 3 sine 1/6 x plus, well, what's 2 pi divided by 1/6? What is 2 pi divided by 1 over 6? 2 pi over 6. What's 2 pi times 6, isn't it? So, what do we got here? 12 pi, isn't it? Right.
Then divided by 1/6 minus 2 times 10.
2 pi, my ugly 2 pi. Divided by, 1/6.
What is after 1/6? Minus?
That's an equal sign. Again, smart board technology does not let me, adequately make. That's equals 2 pi times 6. Remember division, invert, multiply for multiplication? Okay, so the phase shift here is 12 pi units, which direction? To the left. You've already done all these. Caleb, I suspect you may have. It'll end up just being extra credit for you on that. All right, so just identify the phase shift. So what I want you to do, anything that you didn't do through number 12, I want you to just identify. Identify the phase shift for the rest of 1 through 12. Okay? On number 13, y is equal to 1 plus cosine x. All right? Now, to graph this, what we're doing now, 1 plus cosine x, what is that going to look like? We're talking about a translation of the graph of cosine x, not left and right, not a phase shift. This is going to be up and down, a vertical translation. When you have some number added or subtracted to the trigonometric function, when you graph it, you're going to move it up or down vertically. Not stretching it in the context of an amplitude change. I'm not talking about that. And to see what's going on here, your standard cosine curve, we'll call this 1, negative 1, pi over 2, pi, 3 pi over 2, 2 pi. All right? Standard cosine curve, you should know, does this. All right? What does 1 plus cosine x mean? That means what I'm going to do is raise every ordinate or the y value that cosine x kicks out. We're going to add 1 to it. So what's going to happen here, instead of where I start here where cosine at 0 radians is 1, add 1, we're going to go up to 2. All right? At pi over 2, where cosine x is 0, we're going to add 1, and we're going to put our little dot there, okay? At pi, cosine is a negative 1. A negative 1 plus 1 is 0. Then at 3 pi over 2, cosine x is 0. Add 1. We come back up to 1. And then we come all the way over to 2 pi. The cosine of 2 pi is 1. 1 plus 1 is 2. So what happens is a vertical translation. And the graph looks like the graph of cosine x moved vertically upward. And it looks like this. That's all a vertical translation does. It lifts the whole thing up or down. Yeah, if this were 2 plus cosine x, the only difference would be, if the equation was y is equal to 2 plus cosine x, then what happens is all the points are shifted up. I'd have to draw my graph up to 3. All of this would get lifted up to 3, and it would look like this.
We should do more compliments. Yeah,
this is doable, isn't it? So what you do, again, you start with the parent graph, or you start with the graph of, I would graph whatever the trigonometric function is here, whatever it is. Then I would add or subtract, I would go to each 1/4 interval throughout the period. Then I would add or subtract a certain amount that would either move the graph either up or down, the appropriate amount. If this were a negative 1, if I were to have graphed, what would a negative 1? What would y equals to a negative 1 plus cosine x look like? Well, I'm going to take my standard cosine curve, which is right here, all the way around, and I'm going to subtract 1 unit. So I would be here, subtract 1 to here, down to a -2, and have a lowest value of a -2, wouldn't it? Because cosine of pi is a -1 minus 1 is a -2. Coming back up to a -1, and then finally back up to 0. This is what that graph would basically look like. All right? So yeah, it's a rainbow. Okay, so what I want you to do for homework, 13 through 20, I want you to graph 13 through 20. I know the directions say simply find the vertical triangulation, the graph that you have to find the translation, but I do want you to graph those. They don't look as hard as some of the ones I was originally telling you to graph in 1 through 12, all right? Just on the rest of 12 that you didn't do, just tell me what the phase shift is. If you've already graphed those, I'll give you the credit as, as you deserve there on those problems. But 13 through 20, graph those, okay? So we're going to stop there.